The United States is the only country in the world that hosts two active mantle plume hotspots. The most voluminous oceanic hotspot on Earth, beneath Hawaii, and the only active continental hotspot in North America, beneath Yellowstone. In the past 9 days, both have produced significant eruptive activity. Yellowstone's Black Diamond Pool exploded twice in 24 hours, the second blast larger than the first, and also the largest event there since 2024. Hundreds of miles away, Hawaii's Kilauea volcano fired a 650-foot lava fountain for 9 straight hours. Here is what the data tells us about both, and why this is worth paying close attention to. Welcome to the Space Desk. Let's get into it. On Tuesday, April 28th, 2026, a hot pool in Yellowstone National Park exploded. On Wednesday, April 29th, less than 24 hours later, the same pool exploded again, and the second blast was significantly larger than the first. The pool is called Black Diamond Pool. It sits inside the Biscuit Basin Geyser Group on the west side of the Firehole River, about 2 miles north of Old Faithful. It is roughly 100 feet long, deep blue, and until 2 years ago it was unremarkable. One of thousands of hot springs and pools scattered across the Yellowstone caldera, none of which had a recorded history of major explosive activity. That changed on July 23, 2024. Without warning, Black Diamond Pool produced what the United States Geological Survey classified as a major hydrothermal explosion. A column of steam, scalding water, mud, and rock fragments was launched several hundred feet into the air. Visitors on the nearby boardwalk filmed it on their phones. The footage shows people running for their lives as debris rains down. The boardwalk was destroyed. By extraordinary luck, no one was killed or seriously injured. The National Park Service closed Biscuit Basin for the rest of that summer. The April 2026 events have just escalated that story. Webcam footage released by the USGS shows boulders larger than baseballs being launched horizontally all the way to the very edge of the pool. The second explosion, on April 29th, has now been characterized by the Yellowstone Volcano Observatory as the largest hydrothermal eruption from Black Diamond Pool since the 2024 event. And that is the headline. Until July of 2024, this single pool had 0 major recorded explosions across the entire 152-year history of Yellowstone National Park. Since July of 2024, it has produced 3. You need to understand what kind of explosion this is, because the word explosion inside the boundaries of Yellowstone National Park makes people think of one specific thing. This is not that. These are hydrothermal explosions, not magmatic ones. And the difference matters enormously, both for what is actually happening underground right now and for what we need to be watching for next. Here is what physically happens when a pool like Black Diamond Pool explodes. Below the surface, water is heated to temperatures well above its normal boiling point, but it stays liquid because the weight of the water and rock above it keeps it under pressure. As long as the pressure holds, the water stays liquid. The moment the pressure drops, even slightly, the water flashes to steam. And steam, by volume, is roughly 1,500 times larger than the liquid water it came from. That phase change is what drives the explosion. It is, in mechanical terms, a pressure cooker that has lost its lid. The most likely cause of the recent escalation at Black Diamond Pool is something deceptively simple. Hot water in geothermal systems is rich in dissolved silica. As the water cools and circulates, that silica precipitates out and lines the natural pathways through which steam normally escapes. Over time, those pathways narrow. Pressure builds in the shallow reservoir until it exceeds the strength of the overlying rock. The first explosion partially excavates the blockage. The system briefly releases pressure, but because the deep heat source is unchanged, the underlying steam reservoir refills rapidly. And a second event can follow within hours or days, sometimes, as in this case, more powerfully than the first, because the partially cleared conduit allows a bigger pulse of fluid to mobilize at once. That is the leading explanation. It is consistent with the timing, with the increasing magnitude, and with the fact that the USGS has detected none of the geophysical signatures that would indicate fresh magma rising into the system. But here is what makes this dangerous. Hydrothermal explosions of this kind happen without warning. There are no precursor earthquakes. There are no visible changes at the surface. 1 minute the pool is bubbling gently, the way thousands of pools across Yellowstone bubble every day. And the next minute, it is firing rocks the size of a baseball at people standing on a boardwalk 70 feet away. The 2024 explosion happened in clear weather on a quiet morning with visitors present. The boardwalk did not survive. The visitors did, but only because of the angle the debris was thrown. That is why the April 2026 sequence matters. It is not a sign that Yellowstone is about to undergo a magmatic eruption. It is a sign that the local plumbing under one specific feature has changed, that the threshold for a violent event at Black Diamond Pool is now lower than it used to be, and that the next one could come without further warning. So let's address what this isn't before we go any further. The first thing online narratives have done with this story is connect it to the Yellowstone supervolcano. The logic is intuitive. Explosions in Yellowstone, getting bigger, happening faster. That must be a precursor. It isn't. And the science on this is unusually clear. A supereruption from Yellowstone would be preceded by signatures the USGS measures continuously. Sustained ground deformation visible to GPS and INSAR satellites, a swarm of deep, low-frequency earthquakes as fresh magma forces its way upward. Harmonic tremor, the continuous shaking that signals magma movement at depth. Changes in gas composition at the surface. None of these are present right now. The Yellowstone Volcano Observatory has been explicit about this. The geophysical evidence does not support a magmatic explanation. The hydrothermal system, which sits in the upper few kilometers of the crust, is operationally decoupled from the deep magma reservoir below. The historical record backs this up. Lisa Morgan and her colleagues, in a 2009 paper in the Journal of Volcanology and Geothermal Research, mapped the frequency of major hydrothermal explosions in Yellowstone across the last 10,000 years of the geological record. They found dozens of these events. They found craters left behind by explosions far larger than anything Black Diamond Pool has produced. Some of them hundreds of meters across, blasted out by single events thousands of years ago. And they found no temporal correlation between hydrothermal explosions and magmatic activity. Hydrothermal events happen on their own clock. They are a chronic and locally dangerous feature of Yellowstone's geothermal park. They are not supereruption precursors. The actual probability of a Yellowstone supereruption in any given year, based on 3 caldera-forming events in the last 17 million years, is roughly 1 in 730,000. That is the number USGS uses in its public risk communications. It is overwhelmingly lower than the everyday risks of life inside Yellowstone, wildlife encounters, weather, simply driving in the park. What is real, and what is worth paying attention to, is the localized escalation. Black Diamond Pool has gone from 0 major events in 152 years to 3 major events in less than 2 years. That is a localized hydrothermal anomaly. It is not a global volcanic anomaly. The system has changed at this one feature. The reason is almost certainly not what is happening miles below the park. It is what is happening just below this pool. So if not the supervolcano, what? In 2022, a team led by Dylan McGuire and Brandon Schmont published a paper in the journal Nature that quietly rewrote a piece of how we understand Yellowstone, using a dense array of seismometers and modern tomographic imaging, the technique of mapping the Earth's interior by analyzing how seismic waves change speed as they pass through different materials. They generated the most detailed image to date of the upper mantle beneath Yellowstone. And what they found was unexpected. The Yellowstone magma reservoir is not centered directly beneath the surface caldera. It is offset to the northeast. The deep Plume conduit, the column of unusually hot rock connecting the mantle to the surface, does not rise vertically. It tilts. And the deep source at the bottom of that tilted column lies hundreds of kilometers from Yellowstone National Park itself, somewhere beneath what is now central Nevada or eastern California. This finding reframes the entire system. The features people see at the surface, Old Faithful, the Norris Geyser Basin, Biscuit Basin, the hundreds of pools and fumaroles and mud pots, are the visible end of a much larger, geographically displaced magmatic system. Yellowstone, as a geological structure, is significantly bigger than Yellowstone as a national park. The thermal anomaly under your feet at Black Diamond Pool is responding to heat that originates far outside the park boundary. Why does this matter for the April 2026 events? Because it tells you that the layered architecture of the Yellowstone hotspot, deep plume below displaced laterally, connecting upward through hundreds of kilometers of crust to the shallowest hydrothermal layer at the surface, is more complex than the simple picture of magma directly underneath. The shallow hydrothermal system at Biscuit Basin can change behavior without the deep magma changing at all. That is what the data is currently showing. That is what the Yellowstone Volcano Observatory means when it says the events are decoupled from the deep system. The Yellowstone hotspot itself is one of the most powerful geological systems on the North American continent. It has been producing magma for at least 17 million years. As the North American plate has drifted southwestward over it, the hotspot has burned a track of caldera-forming supereruptions across what is now the Snake River Plain of southern Idaho, ending with the modern Yellowstone caldera in northwestern Wyoming. The most recent supereruption occurred 631,000 years ago and produced the Lava Creek Tuff. The two prior super eruptions, the Mesa Falls Tuff at 1.3 million years ago and the Huckleberry Ridge Tuff at 2.1 million years ago, were even larger. This is the only active continental hotspot in North America. There are very few of them anywhere on Earth. Continental hotspots are rare because the continental crust is thicker, colder, and harder for a mantle plume to push through than oceanic crust. Yellowstone has been doing it anyway for 17 million years, and there is exactly one other mantle plume on United States soil, and the place it surfaces is the most volcanically active spot in the Pacific Ocean. The Hawaiian Islands exist because of a mantle plume, a narrow column of unusually hot rock rising from somewhere near the boundary between Earth's mantle and its molten outer core, nearly 2,900 kilometers below the surface. As the Pacific Plate slides northwest over this stationary plume at roughly 4 inches per year, each Hawaiian island gets built, then carried away, then eroded, then submerged. Kauai, Oahu, Maui, the Big Island, and right now, beneath the seafloor southeast of Hawaii, an underwater volcano named Loihi is growing into the island that will eventually replace the Big Island as the active center of the chain. The track this plume has left behind is the longest on Earth. The Hawaiian Emperor Seamount Chain stretches more than 3,800 miles across the floor of the Pacific Ocean, all the way up to the Aleutian Trench, where the oldest seamounts are being subducted back into the mantle. The chain bends in the middle, marking a change in the direction of Pacific Plate motion roughly 47 million years ago. The plume itself has been continuously producing magma for at least 80 million years. By total magma output over geological time, the Hawaiian plume is the largest active hotspot on the planet. More magma has come out of this single mantle plume than out of any other hotspot known, and the only place it currently breaches the surface is Kilauea, on the south side of the Big Island. Kilauea is, in an important sense, the working end of the most powerful volcanic system on Earth. This is the geological setting for the second event of the past week. While the eyes of the country were on a hot pool in Wyoming, the most voluminous active mantle plume on the planet was doing what it does, and it just produced one of its most striking eruption episodes of the year so far. On Tuesday, May 5th, 2026, at exactly 8:17 in the morning Hawaii Standard Time, the north vent of Halemau'umau, the pit crater inside the larger Kaluapele caldera at Kilauea's summit, began continuous, vigorous lava fountaining. The fountain reached a sustained maximum height of 650 feet. That is 200 meters. That is the height of a 60-story building made of glowing molten rock, sustained for hours. The volcanic plume rose to 20,000 feet above sea level, high enough that the National Weather Service and the Washington Volcanic Ash Advisory Center had to coordinate with airlines to route flights around it. Over the next 9 hours, an estimated 6 million cubic yards of basaltic lava was erupted. That is 4.6 million cubic meters. It covered approximately 60% of the Halemau'umau crater floor. The episode ended abruptly at 5:22 in the afternoon Hawaii Standard Time the same day. From start to finish, exactly 9 hours. This was episode 46 of an ongoing eruption sequence that began on December 23, 2024, when lava first returned to Halemau'umau after a brief hiatus in the volcano's activity. Each episode in the sequence has followed a recognizable but irregular pattern, a period of slow refilling and pressurization of the shallow magma reservoir beneath the caldera, a sudden onset of vigorous lava fountaining from one or both vents on the southwestern margin of the crater, and then an equally sudden cessation when the immediate batch of pressurized magma has been released. The Hawaiian Volcano Observatory reported that during episode 46, the north vent did all of the fountaining. The south vent, which has been active in some prior episodes, only exhibited periodic gas jetting and incandescent flame from burning volcanic gases. The volcano alert level remained at watch. The aviation color code remained orange. These are the same levels they have held throughout the active phases of the post-2024 eruption. The lava itself is tholeiitic basalt, the characteristic magma type produced by the Hawaiian hotspot. It erupts at roughly 1,150 degrees Celsius, which is 2,100 degrees Fahrenheit. It is among the lowest viscosity magmas erupted anywhere on Earth, which is why a Hawaiian-style eruption can fountain to such extreme heights, and why its lava can flow as fast as a person can run on steeper slopes. Episode 46's flows did not threaten any populated area. They stayed entirely within the closed-off zone of Hawaii Volcanoes National Park, as the post-2024 eruption has done throughout. But the eruption is not invisible. Tephra, fragments of cooled volcanic material, fell outside the park's closed area, on Highway 11 between mile markers 30 and 34, with pieces as large as 6 inches in diameter. Pele's hair, the fine golden glassy strands of stretched lava that form when fountaining magma is whipped by the wind, was reported as far away as Mountain View. This is the 46th time something like this has happened at Kilauea since December 2024, and the cadence is not slowing down. The post-2024 summit eruption at Kilauea has produced 46 fountaining episodes in roughly 17 months. That is, on average, one episode every 11 days. The actual cadence has been irregular, sometimes 2 episodes within a single week, sometimes a gap of 3 or 4 weeks between them. But the median has been weekly to bi-weekly. The total volume of basaltic lava erupted across all 46 episodes is in the hundreds of millions of cubic meters. That is comparable to the major effusive phases in Kilauea's recent eruptive history, but well below the totals from the 2018 Lower East Rift Zone eruption that destroyed hundreds of homes in Leilani estates. What makes episode 46 different is its placement in the upper end of the distribution for both fountain height and duration. The maximum sustained fountain across the entire post-2024 sequence so far is approximately 1,400 feet, recorded during a particularly vigorous episode earlier in the run. Episode 46's 650-foot fountain is roughly half of that, but well above the median for the sequence. The 9-hour duration is similarly above median. Most episodes end after a few hours. Some run for 1 or 2 days at lower fountain heights. Few have sustained 600-foot-plus fountains for 9 continuous hours. What does this tell volcanologists? The episodic fountaining behavior reflects a shallow magma chamber that is being supplied with fresh basalt at a relatively steady rate from below, but is releasing that magma in discrete batches whenever the pressure exceeds the strength of the overlying conduit seal. Each episode is a discrete pressure release. The vents on the southwestern margin of Halema'uma'u have, over the course of 46 episodes, established themselves as the preferred release points. The fact that the magma supply has been steady enough to produce 46 discrete events in 17 months tells us that the deep delivery system is robust. Whether the eruption will eventually shift to a different vent system, migrate down the East Rift Zone toward populated areas, or simply taper off as the magma supply diminishes, is not predictable from current data. For now, the eruption continues, and visitors to Hawaiʻi Volcanoes National Park, when an episode is active, can witness one of the great natural spectacles of the present geological moment from public viewpoints, at safe distance in an area where the hazard is fully contained. Compare that, for a moment, to what is happening on a hot pool in Wyoming, where a comparable amount of energy is being released irregularly without warning, in a place where visitors stand on wooden boardwalks just feet from the source. 2 volcanic systems, same country, same week, 2 completely different operating regimes. The United States is the only country in the world that hosts 2 active mantle plume hotspots. Most countries host none. A handful host one. The United States, by virtue of its size and its geographic position, hosts the largest active oceanic hotspot volcano on Earth, Kilauea, and the only active continental hotspot in North America, Yellowstone. Both surface systems are operating right now. Both have produced significant activity in the past 9 days. Mantle plumes are different from the volcanism most people are familiar with. The famous belt of volcanic activity around the rim of the Pacific Ocean, the so-called Ring of Fire, is driven by subduction. One tectonic plate slides beneath another, dragging water and sediments down into the mantle, where they lower the melting point of the surrounding rock and produce the magma that fuels stratovolcanoes like Mount St. Helens, Mount Fuji, and Mayon in the Philippines. That is plate boundary volcanism. It is intuitive. It happens where plates collide. Mantle plumes are something else entirely. They originate from somewhere far deeper, possibly from the boundary between Earth's solid mantle and its liquid outer core, nearly 2,900 kilometers below the surface. They rise as narrow columns of unusually hot rock, melt as they near the surface, and produce volcanism in the middle of plates rather than at their edges. They are rare, they are voluminous, and they produce the longest-lived volcanic systems on Earth. Most mantle plumes that scientists have identified surface in the ocean. Iceland sits on one. La Réunion in the Indian Ocean sits on another. The Galapagos, the Canary Islands, the Marquesas. Most of them produce island chains or seamount tracts, similar to the Hawaiian Emperor chain. Continental hotspots, plumes that have managed to push their way through thick continental crust, are rarer still. Yellowstone is one of only a few examples worldwide. The Afar plume under Ethiopia is another. The Pacific Ring of Fire was active in the same week as the Yellowstone and Kilauea events. There were 3 earthquakes of magnitude 5.5 or greater along the ring within 24 hours, a magnitude 5.8 in the Aleutians that triggered a NOAA tsunami warning at Boulder Island, a magnitude 5.5 in the Philippines, and a magnitude 5.6 south of the Kermadec Islands. Mayon volcano in the Philippines continued its ongoing eruption. The Ring of Fire was busy. But the Ring of Fire is always busy. That is what subduction looks like. The story this week is not the Ring of Fire. The story is the part of the planet that doesn't fit on the Ring of Fire. The two mantle plumes that operate inside the United States, and the strange way they have both reminded us that they are still very much active. A handful of viral narratives have already attached themselves to the simultaneous events. Let's address them quickly, because TSD does not waste runtime on bad arguments. The first claim is that solar activity is driving terrestrial volcanic and seismic events. This is not supported by the energy budget. The sun's variability, even at the peak of its 11-year cycle, adds an extremely small amount of energy to Earth's surface compared to the energy already stored in the crust as accumulated tectonic strain. Some peer-reviewed papers have reported weak statistical correlations between solar parameters and global earthquake counts, but these results have been difficult to replicate, and the proposed physical mechanisms remain quantitatively small. The mainstream view among seismologists and volcanologists is that the energy involved in solar activity is many orders of magnitude, too small to trigger crustal failures or magmatic eruptions. The second claim is that the Hawaiian and Yellowstone hotspots are somehow connected through deep mantle dynamics. There is no direct evidence for this. Seismic tomography of the deep mantle has not identified a single shared structure feeding both plumes. The two appear to be independent features, rooted in different parts of the lower mantle. Some larger-scale models have proposed that both are part of a broader pattern of upwellings tied to the African and Pacific large, low-shear velocity provinces, the two great deep mantle anomalies. But whether Hawaii and Yellowstone are siblings of the same deep parent or merely independent neighbors is, at present, an unresolved question. What is clear is that there is no evidence either system is responding to the other. The third claim is the supereruption precursor narrative. Already addressed. The data does not support it. What is true is that the United States has more active volcanic systems than most people realize. There are more than 160 active or potentially active volcanoes in the country, more than any nation on Earth except Indonesia. Two of them happen to be among the most powerful mantle plume volcanoes anywhere. The events of the past 9 days are not a coincidence in the conspiratorial sense. They are a coincidence in the simple sense, the kind that draws attention to a fact that was true all along. For Yellowstone, the question is whether the threshold for the next major Black Diamond Pool event is now permanently lower than it was 3 years ago. The escalation pattern at this one feature is unusual enough that it suggests something has structurally changed in the local hydrothermal plumbing. The Yellowstone Volcano Observatory will be watching for the geophysical signatures that would indicate a deeper magmatic cause. Sustained ground deformation, harmonic tremor, swarms of deep earthquakes, none of which are currently present. As long as those remain absent, the explanation stays in the shallow conduit category. If they begin to appear, the analysis changes. The USGS has not closed Biscuit Basin permanently, but the area remains hazardous, and visitors should treat the boardwalks with extreme caution. The next several months of monitoring are how we will know whether the recent escalation is a transient anomaly or a new normal. For Kilauea, the question is when episode 47 happens, and what comes after that. The pattern says the next episode is days to a few weeks away, somewhere in the cadence range that is held since December 2024. The bigger question is whether the eruption will eventually shift from the summit caldera to the East Rift Zone, where the 2018 Lower East Rift Zone eruption destroyed Leilani Estates and reshaped the southern coast of the Big Island. Right now, there's no indication of that. The deformation patterns, gas measurements, and seismicity are all consistent with continued summit-only activity. But the post-2024 sequence is unprecedented in its duration and discrete episode count for the modern monitoring era at Kīlauea, and how it ends is genuinely not predictable. The broader question is how the two hotspots will continue to behave through the rest of 2026. Both are being monitored continuously by the USGS. Both have public dashboards where the underlying data is visible in near real time. Both are operating right now. The next big test for the Yellowstone hotspot is whether Black Diamond Pool produces a fourth event, and if it does, whether it appears in days, weeks, or months. The next big test for the Hawaiian hotspot is whether episode 47, when it comes, exceeds the 650-foot mark episode 46 just set, or whether the sequence is now plateauing. Or two mantle plumes, one country, both active in the same week. The Yellowstone events at Black Diamond Pool are the largest hydrothermal explosions at that feature since the catastrophic 2024 event. And they raise a real local question about whether the threshold for the next major blast is now lower than it used to be. The Kilauea episode, 46, is the latest in an ongoing summit eruption that has produced 46 discrete fountaining events since December 2024. And at 650 feet of sustained fountain height across 9 hours, it sits in the upper end of the sequence's distribution. Both systems are visible right now. Both are being monitored. And both are reminders that the geological power running beneath the United States is not abstract, not theoretical, and not in the past. We will be tracking what happens at Biscuit Basin and at Halemaʻumaʻu as it develops.